Okay, forgot to start recording. I'll start recording now. So sorry. Okay, with VLANs, normally each VLAN will have its own particular subnet. So maybe if we had VLAN 10, we would use the .10 as the third octet in the IP address. And if we're in VLAN 20, we would use the .20 address in the third octet of the IP address. Makes it a little easier to troubleshoot it later when you look at that. So if the guys in VLAN 10 have 172.17.10. something, and the guys in VLAN 20 have 172.17.20. something, they can't talk to each other. They can't even hear each other. They're in different VLANs. So we would normally have to put a router in there because they wouldn't be able to talk to each other. In this particular figure, PC1 can't communicate to the server because he has an improper IP address configured. His third octet doesn't match properly. So we have to make sure all our IP addresses match. Does the VLAN exist in the switch? We could troubleshoot this by doing show VLAN. Does the VLAN exist? Well, in this case, he's shown that VLAN 10 is inactive. He should have gone back and typed the command VLAN 10 name students or whatever you want to tag it to make sure it would work properly. Okay, how about trunking? Trunking has to match between the two switches. They have to agree upon the native VLAN. So if we do show interfaces F01 trunk or show interface trunk, we can see the status of all our ports that are trunking. In this particular case, the native VLAN of 2 was issued on both sides. In all labs, we normally make the native VLAN 99 for the IT people. So in this case, the native VLAN should have been 99, but the native VLAN was mistakenly configured as VLAN 2, and they're getting all those horrible error messages every 10 seconds on the screen. Oh, native VLAN mismatch, blah, 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 over and over. You would correct that by resetting the VLAN to 99 on the switch that had not been properly configured. Okay, let's look at common problems with trunks. A native VLAN mismatch, that's going to give us constant error messages. You'll know right away that that's taking place. If one side of a cable is configured as a trunk and another side is configured as an access, no network connectivity. They have to match. It's kind of like, you know, one speaks Portuguese, another speaks Spanish. They ain't the same language. If the allowed VLANs on the trunk do not include the actual VLANs you're using, they won't go over the trunk. So by default, if you don't use the allowed VLAN statement, all of them are allowed. If you want to enforce security, you can use the allowed VLANs. Just make sure you actually include all the VLANs that are present. Okay, in this example, there's an incorrect port mode because when you look at this port 3 on the switch, which goes back to port 1 at the top of the triangle, oh dear, it's access mode. It should have been trunking mode. So S3 is sending trunking frames down to S3, and S3 is only an access port. He doesn't know the slightest thing about trunking. He's configured to be a normal access port. So poor little PC4 is isolated from the rest of the network. He cannot connect to the web server. So to fix this issue, go to S3, config terminal, interface port 03, switch port mode trunk, and you will restore connectivity in that particular troubleshooting situation. Oh, in this condition, we have an incorrect VLAN list because when we do show interfaces trunk on S1, he's only allowing VLANs 10 and 99. But there's a student VLAN, VLAN 20. Who cares about the students if they can't connect? Oh, that's right, you're paying all our bills and all salaries. I guess we should allow you to connect. So he went to switch 1 and he added port 20 to the allowed list of VLANs so that they can propagate back and forth through the rest of the configuration. Okay, now we have VLANs in 10, and we have PCs. The students are in 10, the faculty are in 20, and I can't get emails from the students, and the students can't get emails from me. We actually had that situation in our IT department, but they fixed that. So let's add a router to the picture. So here are two possibilities here. I have two networks, VLAN 10, VLAN 30. They both go to the switch ports. And now I'm going to run, I'm not going to make any trunking connections. Those two wires, F1 and F2, that go up from S2 to the router, the router's got 2 ports. The router's got 2 gigabit ports. Just configure G00 as the default gateway for PC1, configure G01 as the default gateway for PC3, and that'll work fine. Unfortunately, it doesn't scale. Most people have more than, if they have VLANs, they will have more than 2. They may have a 1 or 2 dozen. So this doesn't scale up well at all, and we run out of switch ports on the switches, and you can get routers with 24 Ethernet ports on them, but they're a lot more than $750. We can do it with our $750 router easily using a method called routing on a stick. So in the legacy world, if we had different VLANs, we would run separate wires for each VLAN. In this case, our routers only have 2 Ethernet ports. We're limited to 2 VLANs. We can't add any more. We can't scale up in the future. So in router on a stick, what we're going to do is extend the trunking to the router. We're already trunking between these 3 switches in this upside down triangle configuration because we have lots of different VLANs. We get 3 different VLANs in this environment. So what we can do is go to the router and tell the router, treat that cable that's plugged into your single Ethernet port as a trunking port, and look at the tagging and separate the stuff out and pretend it's 3 real Ethernet ports. It's only 1 wire. We're going to create virtual ports, sub-interfaces on that router. So that way we're not limited to 1 or 2 VLANs. We can have as many as we want. Well, we're limited to the 1,000 or the 4,000. So in legacy routing, we have to have the router have multiple physical interfaces. Each physical interface corresponds to 1 VLAN. With our little routers, we're limited to 2 networks. We can't do any more than that. So we can't ever scale up, and if we have future capacity growth in the company and we want to add more networks, we just can't do that. We have to throw that router out and get a more expensive router. And the IT department ain't going to go for that because there's a better way of dealing with it. So normally we would configure the router R1 to be the VLAN 10, the 10 dot network, and the VLAN 30, the 30 dot network. We configure the 2 ports to be the 10.1 and the 30.1 default gateway address for that particular network. But we're not going to use that because that's legacy and old and the waste ports. So on the router itself, just as an example here, we'd go to each port and assign it to be the default gateway. In that black graphic, the 10.1 and the 30.1 default gateway address to the no shutdown, and automatically the router would route back and forth between those 2 directly connected networks. No problem at all, no routing protocols required. Okay, so let's do routing on a stick. We scaled up the company. We have more than 2 networks now. We have 3. So we want to be able to do it. It's called routing on a stick. It kind of looks like a lollipop. That 1 wire goes up to the circular router function. And we're going to use tagging, trunking on that cable that goes up to the router. And the router will be able to distinguish between them because the router can be programmed. He can be configured to say, distinguish these traffics on VLAN 10 and 20 and 30 and route them as if you were a real physical router with 3 real physical ports. So this gets rid of our legacy limitations. And we're going to go to that router port and we're going to create something new here. We've never done this before, sub-interfaces. We can create thousands of sub-interfaces on a router port, but we're just going to do a few of them. Now, to make sure this works properly, I'm going to take that wire and that goes to the router port, and I'm going to configure that F05 trunking cable that comes out of the switch port. I got to configure that to be a trunking mode, not access mode. So he goes into the switch and it goes to, creates VLANs 10 and 30. He goes to port 5, which is connected to the router, and he says, be a trunking cable to the router. We can configure the router to understand VLAN tagging and trunking in just a minute. Okay, here's the good stuff. Let's go to the router configure. Now, I mentioned before this .1Q is the Cisco keyword for IEEE 802.1Q encapsulation, which is what you should be using today. The alternative command in the router is ISL, the old interswitch link. If you have a really old switch that doesn't have the new 802.1Q, you can use that in a very old installation where my doctor's office or the lawyer's office where they're just not going to upgrade their switch. So let's go into the router and let's configure R1 and let's go to that port G00. And this diagram is confusing to me. That second parallel wire that goes to the router, that's not being used anymore. It was being used before when it was legacy and they used both ports, Ethernet ports on the router. We're just using G00 now. We don't even need G01 anymore. That's a backup. It's a spare at this point. So let's go into the global configuration mode and type interface G0/0.10. We have now created a subinterface .10. And the next command, the second command, let's say that command encapsulation .1Q10 that says use the .1Q frame tagging, not ISL, and assign that to VLAN 10. So all the VLAN 10 traffic will be evaluated by that virtual interface G00.10. And just to make it consistent, when we assign the default gateway address for that particular subnetwork, 10.1, 172.7.10.1, 255.255.255.0, the 10s all match. It was G0.10, it was .1Q, VLAN 10, and the third octet of the IP address is 10. That makes it easier to see later. And then there's no technical reason you have to do this. It just makes it easier for you to go back later when you're trying to troubleshoot something. Okay, let's look at the next line, interface G0/0.30. We created the subinterface .30. We assign it to VLAN 30 with encap.1Q30. And then we assign the default gateway address for those guys on that network as 172.17.30.1. Now, we don't shut down individual ports. Virtual ports, they're virtual ports, you can't turn them on and off separately. Instead, you just go to interface G00 like you normally would and type the no shutdown command. And all the virtual interfaces and the physical interface will come up and you can start transmitting bits back and forth. Okay, let's verify these interfaces. Look at the show IP route command on the right. We see our .10 and we see our .30 addresses, and they correspond to gigabit 0/0.10 and 0/0.30, just as if it was a real router with multiple Ethernet interfaces. The virtual interfaces act just like real separate physical interfaces would do. And when we do the show VLAN statement on the left, we can see when we show VLAN, we've got the, on the router, we've got the 0.10 is VLAN 10, and the 0.30 is VLAN 30. Okay, now let's verify the routing. We should be able to now ping back and forth between PC1 and PC3. So you can use the ping command. Oh, it works okay. It was configured properly. Traceroute, which I call ping on steroids, shows us the actual path that it takes. And it went through the one router and the second router's virtual ports, and the connection was completed properly. Okay, now let me see. We've completed the slideshow. Let me stop that and start the packet tracer and see if I can recreate a little packet tracer and get VLAN routing working on here just as a demonstration, so you guys, the next time when you do your lab, you'll see what's supposed to happen here. Let me see. I need to go back to sharing. Sorry. Let's see. Share. Application window. Packet tracer. And I'll have to drag it around here to get it the right size for the get the most on our screen. Oh, it's about as big as I can get it right there. Okay, all I've done here is the pop-up work. Okay, so I pre-configured PCA. I made him 192.168.10.10. He's going to be on VLAN 10, so I made his host name PCA 10, just a reminder it's 10, VLAN 10. I configured PCB to be on VLAN. He's going to be on VLAN 20. Now remember, the PCs don't have any tagging in them. They don't have any. They're not aware of VLANs. But I assigned him another address. I assigned him 192.168.20, and he'll be. I'll assign him to the port he plugs into. I'll assign that on the switch port to VLAN 20. Okay, I need to make some connections here to make this happen. The switches, by the way, the switches and the routers are unconfigured except they have the host name set. So I'm going to go. Oops. I'm going to go to the solid cable, and I'm going to connect the Ethernet port of PC to port 6. Oh, it's off the screen. Sorry about that. And I'll go to PCB, and I'll connect this Ethernet port to port 18. And it's a little bit off your screen. And now we need to make a connection between the router on the stick and the switch port. So I'll go to the switch port and go to port number 1 off the top of our screen, and I'll connect that to the gigabit 01 port of the router. Okay, now they are connected together. We can do some configuration here. So switch, let's go into the CLI for the switch. Drag it down here, we can see it. So let's see if we see the connection here. If I show interface status, does that work? Oops, not incorporated. How about show IP? Okay, so it's rolled off the top of our screen, but we can see that port 18 is up because the PCB is plugged into it. And if I go back up here, port 6 is up, connected. Why is port 1 down? It's plugged into the router. Oh yeah, we have to do the no shutdown on the router port because switch ports are up and up by default if the wire's plugged into them. But router ports are administratively shut down until we go and turn them back on again. Yeah, so I better remember to do that no shutdown on the router port, and nothing's going to happen here. Okay, let me go into the privilege exec mode, go to the global configuration mode, and I want to go to that interface fast Ethernet 0/6 and make sure that he's a switch port mode access. That's the default, but I just want to make sure in case under certain circumstances when you plug one switch to another switch, they can trunk up automatically. So I don't want somebody in the help desk to bridge into that he got off eBay and plug it in and get access to everybody else in the rest of the company when he has no business to it. Okay, now we're going to go to the command switch port access VLAN 10. We decided that who's going to use VLAN 10. Notice I didn't say this in the slideshow. As a courtesy to you, if you don't create VLAN 10 first and then assign the port number to it, if you go to, we went to port number 6 and said assign the port to VLAN 10, he went ahead and created it for me. Okay, now I'm going to go back to the configuration mode and go to interface fast Ethernet 0/18. I'm going to say switch port mode access and switch port access VLAN 20. We're going to make this guy VLAN 20. It's a favor, he created it for me. Now, let's do a show of VLAN. What the heck have we done here? Let's try this again. Let me scroll out. Let's zoom past everything. Can I make this wider so it doesn't? There we go. And you can see that. Okay, so all the default ports are still assigned to VLAN 1. All we did was take port 6 and assign it to VLAN 10. And by default, the default name is VLAN 10. We took port 18 and we assigned it to VLAN 20. Now, they won't be able to ping each other because they're in separate broadcast domains. We haven't put the router in there yet. Now, I have to do one more thing here. That wire number 1, go back to the global configuration mode and go interface fast Ethernet to 0/1. It's an access port right now. We need to make it a trunking port. So switch port mode trunk. Now let's go back and repeat that command, show VLAN. And wait a second here. Show in trunk. It's just taking a lot of work here, and the switch, it should show up right away, and a real switch should show up right away. I'll try it again. Configure terminal interface fast Ethernet 0/1 switch port mode. Let's just take a peek here at the, oh, maybe he's all upset because the router's port is not up and up yet. Let me go ahead and go into the router for a second and do a no shutdown on that port just so that it's active here. I think packet tracer is upset that they're not, the port is not active. So here I'm at R1, go to enable config T interface gigabit 0/1 and do a no shutdown. And let's see if that causes those lights. So, okay, the light has changed to green on the router. We'll have to wait about 50 seconds for the switch port to come up, but let's go back to the switch port and see what's going on. Oh, he changed it up. He changed it up. Okay, so if I do show VLAN now, what's happening? Ah, look, that was it. Packet tracer was all upset because the port wasn't up and up. The mouse doesn't show on the screen when I do this. Oh, it does show. Oh, good. I thought it didn't show. See, port 1's gone. Port 1 is no longer an access port. VLAN only shows access ports. Trunking ports are not shown. Well, where the heck are the trunking ports? I'd like to see them. How about show interface trunk? Look, port 1 is now a trunking port. It's using 802.1q encapsulation, which is the only kind supported in our switch. It's trunking, the native VLAN is 1. Ports allowed, VLANs allowed, all 1,000 of them are allowed. So now I think we've completed the configuration on the switch. Now let's see, show interface status. I don't think it's, oh, it works now. It works now. It was, okay. I like show interface status because normally you would have to type show VLANs to see the access ports and show interface trunk to see the trunking ports. So this shows you that, oh, port 6 is assigned to VLAN 10, port 18 is assigned to VLAN 20, and that's not correct on port 1. It should say it's a trunking port, and it should be no VLAN number in there. But that's a packet tracer issue. Maybe after we get the sub-interfaces configured, it might work on there. So packet tracer is close to about 95% of what a real iOS would be. Oh yeah, didn't I talk to you guys last time about GNS3 and EVNG? And I posted the Cisco24.com website. I posted the iOS file that works well with GNS. You can get GNS3 free from GNS3.com. You'll have to give them your email address, but it's free. EVNG is got more later iOSs in it, but you have to configure it. It's very convoluted and hard to do. Well, guys, I configured them for you, and I have it as a OVA, a virtual machine export file. All you got to do is go to Cisco24.com and look for that directory named EVNG pre-configured and download. It's pretty big. It's 1.5 gigs. And then go and get a free copy of VMware Workstation Player from VMware. And then when you import that EVE file into the VMware player, you'll have Packet Tracer on steroids, and it's the actual real iOS, and it's new iOSs too, version 15, real new ones. Okay, the switch should be configured okay here. Now let's go to the router and see if we can get some connectivity between these devices. Okay, if we do show IP interface brief, see, oh, let me see. There we go. I did a no shutdown on the gigabit 01 port because that way we got that trunking port to come up on the switch. On a real switch, it would you wouldn't have to do it on a real switch, except to get it pinging later on. On Packet Tracer, he's dependent upon some dependencies within the devices. Okay, let's configure router R1 to be the default gateway for the 2 VLANs. Okay. So R1, I'll go to configure terminal, I'll go interface G0/1. Actually, I'm gonna go 0/1.10. And what's, let's see, first of all, I have to say, just a second. First of all, I have to give the statement to tell him what VLAN he's a member of. He doesn't want to give an IP address until I do that. So encapsulation.1q VLAN 10 IP address 192.168.1.1 168.10.1. Give me my mouse back. Okay. And now I'll create the second subinterface. Let me go back to your configuration mode. The interface gigabit 0/1.20. Station.1Q. This is VLAN 20's default gateway with an IP address of 192.168.20.1. I don't do no shutdown on these guys. I already did the no shutdown on the entire physical interfaces of G00. Okay, now let's just do a show IP route. And we can see that we have our .10 and our .20 subinterfaces are there. Everything looks like it's up and up. We should be able to route back and forth between those devices as long as I'm at the router. Can I possibly be pinged to 192.168.10.10? Heart stopping, ARP killed the first one. It works. Oh, thank you, baby Jesus. All right, we got that going. Now how about pinging 192.168.20.20, the other machine? And that works as well. Okay, this is pretty good here. I should be able to go now to PCA. Go to the command prompt. And I should be able to ping. See, what's my address? PCA on 192.168.10. Let's do baby steps. I'm going to ping 192.168.10.1, my own damn default gateway. And that worked. Now I'll ping PCB. 192.168.20.20. And I have full connectivity. So I have two networks, but I only have one wire between the switch and the router. I didn't have to use two ports to do this. So that's a little physical demonstration using Packet Tracer of how inter-VLAN routing works. Okay, guys, I think I've covered everything I needed to cover for today. So when we come back together on Monday, let's just bring this back up here just to review. Stop sharing. Okay, so we covered VLANs and inter-VLAN routing. On Monday will be a lab day, and I'll give a brief collaborate session where I show you how to drive the devices and get them connected for these two labs. I've given you a little bit of VLAN routing, a Packet Tracer help today. And the first lab, 6225, is just trunking on the switch. You'll have some VLANs. They won't be able to, PCs will not be able to ping each other because they're not in the same VLAN. Then when you do the lab 6337, you're going to add a router to the topology, and you'll see what I did with Packet Tracer. They'll be able to ping each other from the entire topology. Then a week from today, on Wednesday, we're going to have our new Chapter 7 with access control lists in the lab all on that one day. Access control lists are kind of like a firewall feature in Cisco devices. Think of a public school environment where the kids under 13 shouldn't get internet access, and the junior high and high school kids should. So we could create a VLAN 10 that are the young kids, and we could create a VLAN 20 with the older kids, and using access control lists only allow the kids, the older kids in VLAN 20 internet connectivity, and do not allow the young kids that shouldn't get out on the internet that connectivity. We can do that with access control lists. So we'll see that and that later on next week. Okay, guys, one final check of attendance. Good deal. Fairly good attendance today. So I'm going to go ahead and lock my mic now and sign off and conclude the recording, and look forward to seeing you guys next week again. Thank you so much. This is Mark signing off and muting off.